Hello, welcome to my YouTube channel. My name is Wahid Lutfi. Let's just start with today's topic, which is Python classes and objects. So I'm going to cover this topic, and I'm going to open a slideshow here. Python classes and objects, and the data structure that we're discussing is a class. Class is the template for objects, like a blueprint for a group of objects. You can create objects once you have defined a class. When you create a class, you could just call it any name. It starts with uppercase letter, and then the name of the class represent a template or the blueprint for all the objects that later on you're going to use for it. And then the objects can be instantiated. For example, last time we discussed the cars class, and the examples of the cars are BMW, Toyota, Ford, and all the other cars that you can create it. Similarly, if you create an object of class employee, full-time employee would be an object of the type class employee, a part-time employee, a manager, system admin, developers, and any kind of key staff employees or part of that one. Let's just go to the topic of today, because I want to just make sure that you understand and that you're already using class and objects all along when I'm showing you all these other videos. So this has been happening for a while now, and we're going to just go through the discussion with these examples of a list, and we're searching some objects inside another object or another list, an element of a list being on a list, and then what we are going to do with it. We're going to show you these examples and some of the critical kind of lines that are like 12 here. I'm comparing line 12 here when I'm working on the object M, which is an element, versus an object on line 12, which is majors, is just a list, the entire list. Then you can see that when you do the majors, you get a count of 2 for computer science occurrence. Here, if you do within this for statement, this for statement, it will show computer science 1 because you're in the element, you're doing this object M dot count of M. So that would just be different, versus majors.count of M would be giving you this 2. That's what is a good comparison of what you can do with member methods and the attributes and the properties. So we're going to discuss a lot of the instance and object and classes with this topic tonight. So let's get started with that. Before we get started, let me just show you the Python class and objects that I'm going to cover tonight. If you go to colab.research.google.com, which is a secure port HTTPS, it will present you this interface. Then here you can just run Python code. So at this example, if I say print help on, let's say something like sum function. If the sum function is there, it will just tell me that, okay, sum function is already a built-in Python function, and it is just giving you the details of that one. So similarly, if I do help on, let's say another one is called, let's say, math.sum. We could do that one, but math is not imported yet. So then that means that if I just run this command, it's going to just say, well, I don't understand this math module. So then you say import this math module, which is also a class or a library, you say import math, and then you say math.sum, and then now sum is not there. So you could say add, if add is there, then you can get the information. But if it's not there, you can get help on the math module, like we know that the square root is there. So you could just get help on the square root or pow function. So each of these methods that are there, as a result of this, you can see, for example, if I do a dir on this math.pow, you can see that it is going to give me a directory list for everything that math has. Similarly, I can do it here. And then the help of this one is basically gonna give you everything here. So now, if I don't import anything here, and then notice that if I just say import math as m, this alias m, and then I could just say dir of m would be the same thing, and then help of m is the same thing. So all I did was just create an instance of this math class, which is an alias. So we're talking about objects and classes. And if I just do type here, and instead of printing the help for it, to get the help, I'm gonna say type here, and then I'm gonna also print type of math module self. So those two are there, but math is going to just say, I don't understand this one yet. Let me just take this one out, because when I say import math as m, it recognizes m, but math is not loaded. So this one was just saying that I don't understand that one. So now you can see class modules. If I just do import math, now m is not recognized. So I can say math here and dir of m. I just don't need a dir anymore. I'm just going to do this, and then I want to get those type. So type is already done here. Let's just do only that, just to show you that when you do a type, this is saying that it is a class module. So it's a module, and then at the same time, I can just define a string, for example. Let me just define a string. So if I just say, let's say message is equal, and then I'm going to say Python programming is cool. Just writing this message. And then I could just say P1, for example, for Python. I could just create any variable here and just say something to it. I could say P1, I could say, for example, Python is elegant. I could just say this Py is elegant, and then put the message here, Py is elegant. I could be more descriptive. It would just be nicer. So now I say Python is elegant and simple. Simplicity of Python is really good. So you can just type in Python is elegant and then simple, or you could just say Python Py underscore elegant underscore simple. 3 letters there. You could just define it like that as well. So whatever the variable that you declare, it holds that as string. So now if I say print a message, and then it will print the message, and notice that I haven't done anything with the other ones. So message, I just wrote a little bit different than what I wrote here. And then I just need to put a message here with A. And then just that is gonna say this. If I just want to shorten it with MSG to make sure that I don't have any typos, I could say MSG, and then here I just have to change it to MSG. Now the other one is not recognized as a variable. So, but now notice the first one, if I do a type of print type of MSG, it's gonna say this one is basically as a string. And then if I do check on the elements of this one, print a directory of this, not element, the directory of this one to see what are the methods and attributes and that are associated with message, then I could say printer of a message, and you can see there's a big list of commands that I can do, like uppercase, translate, and titles, and so on, as well as all these double underscore. So if I just want to say, for example, instead of doing this one, just say print for statement for item and message, and I want to just say if the string is double underscore init and item, then print that one. So this would just print only the items that are on double underscore, start with double underscore. So this one will just do that. Notice that reason I'm showing you this, that you could just say Python is cool and then print double underscore. So and let's see, double underscore and item, and see why it did not print this one. Oh, because here the message itself is just this. So when you're looking at this one, this message does not have anything. What I meant to do is to do a dir of message. Now, and dir of message will have all the methods, and then it will just represent those ones and shows the message here. Similarly, if I just say if this not in, then the double underscore is has to be there. Let's see why it is just saying if not in for item and dir message. If this one is this, let me rewrite this one. It is not working properly as I meant to do that one. So I'm going to say for item and dir of message. So dir of message, and then I say print item, and then now you can see that the item is basically as matching all of the fields that I wanted to print out. And I really wanted to print it on vertical, so you can see all the list on the top to bottom with everything. So now what I want to just change that one, say if item, if double underscore in item, not in dir of message. In item, earlier I think I made a mistake typing dir of message or something, or whatever I had written. I don't recall it, but that was a typo there. So you have to make sure that you don't typo. So now you just see that it's all the double underscore with that method is showing up here. And then if I say if item not in, if a double underscore not in there, then shows me the ones that are all these fields that are there. That these are all the functions. So then if I could say item, print the item as well as on the method's name or function name. So I will just have to pause here for a second and tell you what is the difference between function and methods. In functional programming, a function is called a function. In object-oriented programming, a function is called a method. That's all the difference is, basically. But with method that you define it, there's different terminologies. A variable in function programming is called a variable. In object-oriented programming, you could call it attributes or properties. And then object, it has associated attributes and properties, as well as a method that are associated with it. So an object could have multiple methods. Methods are just basically, if you say human being is a class, and then Wahid is an instance of an object or instance of the class human, then you could say Wahid has certain characteristics. All the characteristic that I have, or attributes or properties that I have, is my height, my weight, my name, my age, my job title. Everything is attribute or properties that is defining me. But then at the same time, functions that I can perform in life. I can walk, I can talk, I can teach, I can play soccer, I can study, I can learn, I can be a nice person. All of that quality is my behavior or methods that I can do with in life, how you perform. Similarly, every object, every human being, a student could be an instance of a class human, or a class pillar, or a class. So there's a lot of concept of inheritance, polymorphism, encapsulation, abstraction, that we're going to cover on all those topics there in details. But for now, you should know that there's classes that is attributes, classes that's like a blueprint for like a group of objects or instances. An instance or object has attributes and methods associated. So right here, and when I say item here, item is the actual item that I'm printing. But if I say, let's just get the items here, and then I want to say and print the type of item to see what are this each item, what are they, and then you can see that they are going to be defined as printed here. The list is going to say this is a class string first, and then capitalized is a class, but it is a string method. And then it is just showing you as class string, because each one of them, as soon as you define one character and you say define it, let's say if I just comment these lines out here for now, and put comments here. And if I just say, for example, here, A is equal A, the character A, lowercase a, is there. Print type of this one is gonna say class A. Even though it's one character, in most multiple languages, you will see this one as a character. Whether you do it single quote or double quote, it will be a string. So a string on multiple other languages are defined as 2 or more characters. But in Python, as soon as you put a character or a number or anything, even if you put a number within this quote, quotation, whether single quote or double quote, it will say it's a string. But if you want to print this one as integer, you have to do 1 as integer. You can see that it is there. Similarly, if you want to get this one as a floating point, then the type would be saying floating point and there. So let's just go back here with our other example. I'm going to delete these 2 lines. If this one was like, just say the word false, and then notice that it's a Boolean class, or it was true. So all those data types that are defined, they have their own specific one. So if you look for that type of dir, and you say, let me just see the dir of that one, I want to see what are the directory. All of these methods are for the type Boolean operators that you can do work with that object A in this case. So let's just clean this one up, and then and go here back. So now we printed this one. If I just wanted to get the method of those ones, as you can see here, for these two lines. This is cool because what you wanted to do is just as you are printing the class, you're going to just get the type of that method that are there. So similarly, if you just say here, take the not out for the double underscore method, you could see that is there operator. So now this, we're not limited only to this n and r and this. You could just say if item and this, or let's say or item and upper. So if you just say if item contains that one or upper, just show me the upper also. Notice here is upper here. So if you just say and statement, this is not gonna return anything because those two conditions are not true at the same time. These Boolean operators that you're doing between two object or two instance of a string, you're not going to get that one. So rather than do this, you either do this item and this, and then if you want more than just upper, you could just say if item and this, or item and lower. So you can get those two and the condition, and you just get both upper and lower listed here. And then if you just again change this one to and, this is not going to happen because this is the item cannot be upper at the same time and lower in that case. So make sure that if you're intending to just match those two, you could do that one. Okay. And then I'll later on show you, for example, the conditions where you can actually check in the state of item and this, or item and this, and then and so many of them. A better way to do it is to create a list of all the objects, and then you check on the item, say for if the item was found on this one, and then you could do it on that one as well, which was the topic of tonight's discussion here with majors, all these field that I already have it, and so I'm going to do that one. But let's just say I'm going to delete these lines here, and then this line that I was saying, print message. So the message now is a string, and now what I could do is say if I want to change the message in uppercase, because it is object-oriented programming, message is the object here. So I could say dot, and then a certain method that are available with that object is gonna provide me the IDE of Jupyter Notebook. It's just basically helping me say which one of these methods you want to use. It gives you a bigger list here for all those ones when we did the directory. If you're not in the IDE, you have to memorize them. So this one, I mean, nobody memorized millions of functions with arguments and every programming language, but it is good from time to time to just memorize certain things that you use the most, and then from time to time you just do that one. So now if I just call the upper method, it is just changing everything to uppercase here. And then similarly, if I do to lower method, lower method, notice the dot operator here. The dot is just basically saying this is a member of this method, or this method can be executed upon this object. So dot lower is the method that message can use, but lower one is not, because that one, as soon as I type in lower one, and notice that lower one is just going to give you error because that method is not defined, or in the class string, that method is not there. If you have to do that one to lower one, you have to write your own function to do this one. So as a simple way, let's say I just say def, and then say lower one, and then I could just say this, and then here I say, now I'm gonna say return, and then so I'm going to just get the message, whatever is the message here. I'm going to get this one as argument, and then I'm say message dot lower, and then that would return it. And then here I could just say the message is there, and lower one. I could call it like lower one. Now let's see if that one is defined. Lower one is not defined here. Def lower one as message, and just 1 second. Let me just read what I'm doing here. A string object has no attribute lower one. Yeah, because this lower one is not part of user defined. So I mean a system. This is a user defined. I could just create something else here. I cannot associate with this message. That's what this one is. So if I just, instead of doing this one, I change this one to lower one, lower, that would work. But then for me to just change this message here, I could just say here, and instead of that, I could say print, and then I have to use it as a functional programming, which is lower one, and then give the name of MSG as an argument, because lower one takes one argument, and now I'm passing it that way. Then now it is in lowercase. And then if I just want to have my uppercase function similarly, look at this one, you just copy this one, and then do this, and then just say upper one, for example. This is upper one. And then here you just have to call in the upper method. The upper, and then here you are going to just copy this one, and then just say this one to upper. So code reusability is really easy. You could just do a lot of things with object-oriented programming as code reusability. You can see that I just created two functions or methods here, and then now I'm just passing message. If I just want to pass the message, sorry, to lower one, and instead of this one, say Python is elegant and simple, then I could just do that one, and it will just say Python is elegant, this one. And if here you could see that while you're doing lower, you can just say change it to back to upper. You upper one here. You don't have to just use the kind of one technology versus other one. Notice here, I just change it, same function that I wrote here. Or I could do something like here and say to lower, and then if you want to change this one back to upper, let's just write this one to lower here. So what I'm showing you here is just object-oriented methodology. So you can just say, okay, I'm having this output as lower, but now I want to convert it to uppercase. And then notice that this one is not taking it for some reason because of this argument, but I believe this one is right here, the problem. So I just have to close that one, saying that this is the instance that I want to just operate upon. So dot upper will just convert it, and it will work on this one. This is second item is for line number 10. And it's cool because the color even shows you that it's there. So if I highlight this one, line 11, and then line 11 is the output is right here. At the same time, while we're doing this one, I want to show you simple things about an object and attributes of it. So the object in the classes is going to be, we already covered the cars. So I'm going to cover another one with pillars class. I'm going to define someone. But before I get that one, let me just clear this screen, and I'll show you this class here. Okay, so I'm going to have these three lists. So let's create these three lists. First, I want to show you what are these lists. The first one, majors one, is called computer science, math, and electrical engineering. These are elements of each of the class here, math and this. This is a second list, major two, and it's having about three majors, which are all the strings here. And then this last one is majors is basically empty list. So if I say print type of majors and then comma type of majors, let's say I'm going to do the first one, majors one, and then the second one is majors 2, and then that third one is type of it is a type of majors at just itself. Okay, so all those ones, if I print it, you can see that they're just getting is the first one is class list, the second one is class list, and the third one is class list. If I want to just have a new line character, I could just create a new line character for each one of them also, and then do a new line character. I could also add it. Last time I wanted to add some string here. I could do plus add a new line character here. Let's say if I want to do this one, and then comma. So this one is I'm gonna do, I have to do a plus, and then type of that one, and then plus type of that one. Let's see if I could get the list here. For some reason, I need to do it differently. Turns back. So it says unsupported operator type for plus type in the string. So here, this is the type is just showing you a different, and this one is a string. So it is not supported this way. What you could do is just write each one of them separately, and then do this, and then say print. And this would be easy to do it. Otherwise, you have to cast it, and then do this, and then do the last one, print. And this would just be as easy as you don't have to cast one data type to the other one to just convert it to string when you do concatenation. But let's say the way this complaint was, if I say string one is equal this, and then string 2 is equal, this is a simple test. So if I just want to concatenate the two of them, I could say print is 1 plus is 2. That's not a problem. It will just say this is a simple test, but notice that there's a space here. So if you don't have a space here or a space right in front of this, then you can add a plus and just concatenate another string to it with a space. So now notice that we're using operator overloading in object-oriented programming. This operator is overloaded with multiple arguments. Each argument is a string there. So it is just, you can do operator overloaded, like print 2 plus 5 times 10 plus 2. Let's say we just do that one and we get a value. Notice here we get 54. And if I just do this one within the bracket, another bracket times this one, the operator precedence is going to take effect, and it is going to say, well, 10 plus 2 is added first is 12, and then times 5 is 60, plus 2 is 62. So that's how the operator overloading is. I'm going to carry this operation first because of the parentheses, the precedence of the operator. But notice that operator overloading, meaning that we're just creating multiple different arguments. So even if I say 2 plus 5 is equal 7, that will just be an operator here carrying two objects here. If the object, one of them is 5.5 is a float, the value will still be calculated as float here. And if I just say, give me the type of that one, type of 2 plus 5, this would be just converted with casting or automatically. So Python is not strongly typed, meaning that you can just on the fly change a variable to have different names. So for example, here I could just say 2 here and then here 10. And now I just get the value of s plus s is there. Now this one is going to be a problem because this is a string and these are variable. So in order to do this one, you have to do a string of s1 plus a string of s2 plus that space. Then now you can just convert it to that data type, and then it's gonna just say, okay, 2 and 10, it's gonna print it. But notice it is concatenated. So if I just don't have this 2 in space, now operator overloading is giving the object of polymorphisms. On class polymorphism, one of the paradigm here is that depending on the string that passed in, this operator is acting differently. So now this to a string, it is adding them together as a string. Concatenation, it happens plus rather than addition. If you want addition, then you just have to say, don't convert it. Excuse me. Don't convert it to a string just to do the addition here. Notice this one is going to just say and the addition of 2 and 10 is 12. So this is the difference. This operator overloaded when one time it does with addition of two numbers. When the objects are a string, it's doing concatenation. That's also a concept of polymorphism. The operator or the operator behavior, in this case plus, it is carrying two different operation, polymorphism, multiple forms. So let's get back to our examples of this, because I don't know when I'm going to just stop. When I start on something and then I carry on some more information. I want to be useful for you, so you can just do as many things as you can and learn it faster. So I'm going to just define these classes here that we just talked about it. I mean, this list here first. So let's go to this list here and then delete line 1 here. So now we have these three lists, and I don't want to just, let's just print them here. So print actually, and the print in everything is, I'm going to do it right after I do some updates on it. Let's just do the updates. So here, what I'm doing on line 4 is majors.extend. So majors first, if I just print majors here, print and then majors, and notice it's an empty list here. First one I printed. This one is an empty list right here. So now print of majors 1, and major 1 is this list, which is the top one. Major 2 is this one. But now I'm going to grow major 1s first to with this one. So if I just do this one, I print it, and now I'm going to just print one more time, say print majors. This time I'm going to have the majors as the same as majors 1. And then the second time when I print this one after concatenated or extended the majors 2 on it, and then it's the entire 2 field together. So let's see what is print. I missed a P here. I just cut and pasted with one letter missing. Oops, sorry, what happened there? Okay, so right here, print. And then this one now is gonna just say that this is a bigger list here. So I'm not gonna print this one because we know that it's an empty list here. I'm not gonna print this one. We know that it's and this one is added. So this one is added. And then this one is okay because we want to print after that third one on line 6. This is the entire majors there. But at the same time, I'm printing majors 1 and majors 2 here. So you know what's going on here. Now I'm going to do a statement here, say for M, for which is a major, and majors 1, do. So majors 1 do. I'm going to say F, M, and majors, sorry, majors. And then we're going to say print M, just to print it, see what we get here. If you print this one, you can see that those of one that are majors 1 list. So this M is an element or index of this one is computer science, math, and electrical engineering. So since it is there, we're going to check if this one is in the bigger list of this. Since computer science, math, and electrical engineering are there, it just printed all of them in there because we say FM, meaning if computer science, if math, or EE. Within this for statement, it traverses through out of each one of them. So once it goes in sequence, it's gonna check that to see if that is in majors, which is it is there, and then print it. And at the same time, I want to just say print m.count of this m. So notice that here's a difference, slight difference between the two. So if I just say m.count of math, I'm just looking at this field that I found out these 3. I just want to count on each one of this. Even though computer science was inserted on line 7 the second time, I'm just still looking on an object here that m.count. M is just one element, which is within the for statement. So it is not the entire majors. If I want to get this computer science twice, then I need to say majors, do the count of that one. That's important. So you just now getting to computer science there. So now if I just insert another field here, say majors.insert, and then I could insert one in art. It doesn't have to be on the same sequence of 0 always to insert it. Anywhere you want, you can insert it. Insert the statement takes one argument saying that 2 argument. One argument is the index or the index where you want to insert it, and the second argument is going to be there for you where you insert it there. So now art is here and then also inserted here on the majors there. So let's see why on the when we printed art is showing only once here. So I'm going to look at print majors art, and then we insert it. So the element here we're inserting is, let's just see if we insert it on the first element, make a difference or not. No, this is art is there, and Oh, the reason this doesn't matter whether it's index of 0 or 1, art, we don't have it on computer science here. So that is okay. But if I just say majors dot insert and then 1, I add like, for example, electrical engineering, and then just say majors dot insert and then add on 0 math. Now math and electrical engineering should also return 2. So you can see that is there. So let's just, instead of art, we just insert computer science one more time. So computer science should return 3, and it does. So this is how you are going to check for each one of these elements. And then as you can see, we extended these ones. You can add or insert on the other ones. So for example, if this one was just an art here, art here, then it is going to not show here because art is not on the first list. But let's say I go here and say art just added here, instead of just inserting on the first one there, you can see now art is showing 3 times, because the first time it was there, then we inserted here as well as incremented, because major 1 and major 2, it was extended a couple of times on these other statement right here. So that is why now the art actually is 3 times. That's 1 time, that's 2 times, and let me see why it is showing 3. I'm gonna run it again. So art is 1, 2, and then here we are having it 3, and art is there 3. So insert it there. I believe when we print the last one, if we print majors, let me just do one more last statement here to see what is in the majors at the last statement. So we're going to print majors here and compare it to see if, now notice the artist has 3 of them, 1, 2, and then 3. So somewhere here, I just need to have this one insert statement moved out to the previous line, because when we are doing a comparison, oh, yeah. The reason is this one is we're looking at the major 1. Major 1 is just having that field 1, but in majors there, and then majors there. So it should still look at the name here. I'm gonna just shorten these names, major 1, so I don't make any typo when I meant major 1, major 2. This is how you could also do this one for these majors. So this one, majors, is M, and then M, and then everything that I'm doing majors here is M, and then M1 for message. Let's just do that one quickly here. M2, and then this print M, and M, insert it to the M, which is the majors, insert it here. I could do use VI on the set tutorial to modify them here also, but I want to just do it. It's not too many lines here. We could just modify it on the fly. So this one is there. Let's just make sure that there's no typo, because sometimes we meant majors, sometimes we meant major 1, and so on. I will just look at that one. M. And then here, I'm going to just define this one as item for item. and then here I'm going to say I for item, and then here I'm going to do I, and then M is there, and then here this is I. So you have to know these for statement, other ones, in order to know that which one is which, and you are getting the same result here. And then 2 and art is 3. So art is 3 here, because now we are getting the right value. I think it was I'm not sure what was the reason we were getting art 4, I believe, or something. Maybe because I had a typo somewhere when I meant majors. I was typing majors. So here, how many times the art is 1, 2, 3, and that's okay. So if I just want to get another count to be sure, I could say m dot count, and then just that would just return the count of art. And then here you have to give the argument as art. And then you can see it's 3 here and then 3 here. So it's both of them are accurate. And then you can just here say, for example, just to say whatever message you are doing it, is say art, and then the number. When you put a comma separator, this one is not a plus operator. So now you can put a string as well as an integer. You don't have to convert it to a number string with plus symbol. So this is the one that I wanted to show you today. Again, this art uppercase and lowercase are different. So if you're comparing two strings when the comparison, you just have to say if that case is all uppercase, you have to convert it to upper. Okay, I just want to show you that one also quickly since I talked about it, and then we end this video. So let's say I define something, say MSG1 is equal, say hello, and then MSG2 is equal how are you, and then we say if MSG1 is equal, and then this time when you say equal, that to operator, and then you say hello, and then what you want to do is it says print MSG1. So if you just want to print that message to compare a message, it does that one. Now notice that if I just change this one to lowercase h, it's not going to say that message. And say that else you're going to say print message 2. So instead of hello, you're going to say how are you, and then let's put this question mark for how are you. So now it says how are you, and notice that this is the message. So hello is in lowercase, and if I just say if message dot lower, this one, because that string is message 1 is converting it to lowercase. Now we're comparing it, and hello is a lowercase, and it just compares that one, and then it writes the message. So this is how simple you could compare this one. With that equality, in this case, is the ensemble. You can compare a string as well as integer, as floating point, Boolean operators. And this is just basically some condition that you could put it into between braces, and then you could just say this, and then you could say and true. For example, this is just these two conditions will always be true. But if you say and false, that condition is going to be not true, then it's going to come to this message. Or if you say if and 5 is greater than 10, 5 is not greater than 10, so it says how are you. But if you say 5 is greater than 1, obviously it is greater than 1 or 4, then it says hello. So this operator And is another thing, you can do a or with it, and then say or 5. Now this is a short circuit. This statement is computed, and right away you get the output of hello and messages. So whether this one is true or not, this one is going to just be a or statement. If I change this one to and statement, these both condition true and true has to be true in order to execute that next statement. So that is what is going to happen there. So if you just make this one, let's say 0, which is not true, then it's going to say, how are you, which is the else for. Okay. So and or operator, all Boolean operators, we're going to discuss more of them. But since we were talking about these variables, I wanted to make sure you understand what's already available in Python. And then you are going to later on do user define, which we created classes like basically cars. The next one, I'm going to create another class called example. So stay tuned for that one, and I'll post that one as well. Thanks for watching. Take care. God bless you all. Bye-bye now.